In this lesson, we're going to look at surface water movement. We're going to talk about how stream channels form and where they form and how they can move water around. So one of the things that affects stream channel development is runoff. Runoff is any water that is coming over the surface of the land and it doesn't soak in. So it's going to move over the surface of the land. It's going to move downhill, like we talked about in the last lessons about how gravity pulls everything downhill. Water is obviously the same. So it's going to pull that water downhill until it goes down into a lower area, and that's where we're going to get our streams to develop. So the more runoff you have, the bigger streams that you're going to have. The less runoff, the smaller your streams. So when we look at what determines the amount of runoff, obviously the amount of precipitation is one of the things, but it also depends on some other factors, and one of those factors is the type of your soil. So the pore space is that space that's in between the grain particles. So if you think of sand and you hold it in your hand and you've got all the little pieces of sand in there, all the air space that's in between those pieces of sand are the pore spaces. And depending on how much you squish them together and what size the grain is and what shape the grain is going to determine how much actual air space there is in there. Anything that has airspace, if water comes, can fill up with water. So if you've got large grains here, like your sand, we're talking about really coarse sand here, or little pieces of gravel or something like that, then you're going to have bigger open holes, which means that the water is going to move more easily through it, which means that you're going to have more water soak in and less water run off. When you have fine grain sizes, they're able to be compacted closer together. So if you've got fine grains and they're loosely compacted, you're going to get some water that's going to soak down in there. If it's like here where we've got lots of clay, and clay particles are really, really small and fine, they pack totally together, and that's why we get puddles everywhere, and that's why we get flash floods, because the water doesn't soak in and all of it becomes runoff. The mixed grain size acts a lot like that too, because now you've got all these little fine particles that kind of get in between and get in all those holes and spaces in the gravel or the bigger stuff, and now you've got no water moving down there either, so you're going to have more runoff there as well. So when you've got lots of space in between your particles, you're going to have lots of water soak in and not much runoff. When you don't have that space in between the particles, nothing can soak in, and so the only place it can go is over the surface of the land. So we said precipitation, the amount of rain that there is. If it rains more than it can soak into the ground, which is what infiltration is, so if there's more rain than what can soak in, it's going to become runoff. So what's happened here, particularly in the summertime with our monsoons, is that it rains really hard, really fast. The water doesn't have time to soak in. Our particles are so close together that it all becomes runoff. So our precipitation is way exceeding the ability of the water to infiltrate or to move into the ground. How much vegetation there is also will help. Vegetation tends to slow down the rate that the water is hitting the ground. So when the rain here hits the trees or the rain hits the grass, it's going to slow down the speed of the water, and the slower the water is moving, the more likely it is to soak in. When it's raining here like crazy, okay, the water is hitting the ground so fast it can't soak in. And if you're in a dry desert area where there's not a lot of stuff on the ground, there's nothing there to help it. When you're in a grassy area, you're less likely to see that kind of flooding because the grass slows it down, allows more of it to soak in. Now, obviously, if it's raining like 2 inches in an hour, the grass isn't going to help all that much, but it does slow it down a little bit. We talked about slope, right, being one of those things that affects how much erosion can happen, and it also affects the amount of runoff. When you have more runoff, you're going to have more erosion, right, because it's going to move more of the particles. So that steeper slope, once again, it's going to speed up those water particles. They're not going to have that chance to soak in because they're going to be moving downhill really fast. So steeper slopes mean more runoff. Shallower slopes mean less runoff. So the water runs over the ground, it runs off based on how much rain there is, if there's vegetation, and the type of soil. Eventually it's going to run off and it's going to go into a stream system. Some of our stream systems are really small systems, and some of them are really, really big systems. So the smaller streams are called tributaries. So on here, all the ones that are numbered with 1s are our smallest tributaries. These are going to be little things that come from springs, or they might come from the tops of mountains that only get water in them as it rains, kind of like what we get here. But these are our smaller ones. They're like brooks and little streams. They're going to feed into bigger streams, which are our number 2s on here. So we're getting bigger. We're going up in order of size. The secondary streams are going to then go into the main stream. So the 1s and 2s are tributaries. In this one, the 1 is a tributary to the 2, the 2 is a tributary to the 3, and then the 3 is a tributary to the 4. So the 4th order stream is, in this particular hierarchy, is, in this example, is the biggest of our streams. And all these little ones are called tributaries. Now, all the water in one area that feeds into one of the major, like the 4th order streams, is called a watershed. So the picture here that you're looking at, this is the Colorado River watershed. This is every drop of rain that falls within these green boundaries on here. If it becomes runoff, is going to go into the Colorado River and end up in the Gulf of Mexico, or the into Baja, down here. Okay, it's all the Gulf of California, sorry, into the Gulf of California. So if it soaks in, that's a different story. But if it becomes runoff, it's going to move into, here's our little streams, our little tributaries, going into our bigger tributary, coming down here into the Colorado River. So there's a lot of water that ends up in there. And if you look at it, almost all of Arizona, anything that becomes runoff, with the exception of these little chunks down in here, goes into the Colorado River. So the Salt River, the Verde River, all of those will end up going into, they go into the Gila, which then goes into the Colorado River. The divide says where the breaking point is. So like there's all these lines around the outside are divides. So the water that falls on this divide right here that goes through central Utah, that's a mountain range there. And so all of the, I think it's the Wasatch mountain range, everything that falls on the east side of the Wasatch will go into the Colorado River. If it falls on the left side of it, it may or may not, depends. Most likely not going into that area. Oops, I missed a picture. So this is our Continental Divide, and the Continental Divide separates the halves of our country. So it's not obviously right in half. But on the Continental Divide, everything that falls on the west side of the Continental Divide goes to the Pacific Ocean, and all the rain that falls on the east side of the Continental Divide is going to end up in the Atlantic Ocean. And obviously, giant mountain ranges are what are dividing us, and for us, it's the Rocky Mountains that are dividing the water that goes to the Pacific from the water that goes to the Atlantic. This is the Mississippi River watershed. It's about 2/3 of the United States is what drains into the Mississippi River. It's a huge area that's going down into that river, which is one reason why it's so big, especially as you get down here below the Ohio River. The Ohio River and the Missouri River are both big rivers in their own right. The Ohio River is one that has massive flooding almost every year because of snow melt. And the Mississippi River does also, because when the snow melts up here, all that water dumps into the Mississippi and comes down. So big area of our country that is fed, that feeds into the Mississippi River, which is one reason why in the last lesson we were looking at deltas and we saw all that sediment coming down and making new land down there. That's why there can be so much sediment, is because look at all this area where rain falls, and when water falls it picks up sediment and then goes into the tributaries, which then goes into the other tributaries and goes into the main channel, and all along it's picking up sediment. So how much sediment it can carry is known as the load. And we're going to talk about the 3 different ways that stream load can be carried. The first way is through suspension. Suspension is, you can see the particles, they're still by themselves. So like if I were to take some of this dirty water over here that's got all the sediment in it, if I took some of that and I set it over to the side, it would settle out. I could dump the water off the top. I could end up drying it out, and I could have the same sediment that actually went into it to begin with. So these are physical particles. and they're moving along. They're usually really fine particles, and they're usually up towards the top of the water. The bed load, in the bed load, the rocks move along the bottom, and this is the bigger stuff. It gets tumbled along the bottom of the river or the stream bed. So that's one reason why we see river rocks and things like that that are so smooth like this, and that's because they've been tumbled around. The ones that have the sharp edges are either newer to the area, or you can see how this one is sharp edged on this side and very smooth on that side. It means that it got broken in half. So it was one bigger rock and it broke. Physical weathering. The last way that water moves is in solution. Solution are the chemical sediments. So when we talked about chemical weathering and we said that water will dissolve away parts of the rock, that's what's in here. So this part of it is not those pieces that we can see. Usually these are really, really small, if not microscopic, and they're going to move away in solution. So this is different than the suspended load. These are the lightest particles, so they're at the very top of our water channel. The heaviest stuff is going to be down here at the bottom. The suspended stuff will be above it. It's heavier than this stuff that's in solution. How much the stream can carry is going to depend on the speed of the water and how much water there is. So the Colorado River is a pretty decent sized river, but it's nothing compared to the size of the Mississippi. The Mississippi can move boulders the size of cars, right, on a regular basis, not during flood stage or anything like that, but just all the time. There's a lot of water moving really fast through the Mississippi River. The slope that the stream bed goes on is going to determine how fast really the water is able to go. The Salt River, when it's flowing, has not very much water in it, so it's not going to be able to carry very much. So when we talk about carrying capacity, we're talking about how much of that load, how much of that bed load, how much of that stuff in suspension, and how much in solution is our stream going to be able to carry. So what you're going to do now is you are going to, as soon as this video is over, you're going to go ahead and open up Paint. And you're going to draw a diagram that shows the 3 ways that streams can carry their load, which is what we just looked at, and the size of the sediments that's moved by each one of them. So if you're talking about bed load, what size of sediment is carried in the bed load? And your diagram should be labeled with where is the bed load, where is the stuff in suspension, and where is the stuff in solution. You're going to then save your you'll save your paint that you make, your diagram that you make in Paint. You're going to save that as a JPEG file, and then you're going to upload that into the assignment section. You may not go out and just copy and paste a diagram. You need to draw your own. You may look for one to reference, or you can go backwards in the video a little bit to the diagram that was in the video. But you may not just copy and paste. If you turn in an actual picture from somewhere else that someone else made, you will not receive credit for the assignment. Please make sure you're doing your own work.